Lesson 53, Adding and Subtracting Polynomials. A monomial is the product of numbers and or variables with whole number exponents, and that's important. So some examples of monomials that they give us, like my pen tool. Okay, we have x by itself. We have this x to the third over 4, and it says product. Okay, but we could write this as a product by writing it as 1/4 times x to the third. So this is a product of numbers and or variables, and it has a whole number exponent, so that works. This is a product. Their exponents are both 1. Those are both whole numbers. That's fine. Same thing here, and 5 is just a number. Mono, you should remember, means 1, so it's a single term. Things that are not monomials. 1 over x. And I know that this looks similar to the x to the third over 4 that we just talked about, but the problem with this is that we have 1 over x, which is right now to the first power, but we don't want to have these variables in the denominator, so if I move it to the numerator, that's going to change it to x to the negative first, and if I do this, it's no longer a whole number exponent. That's the problem that we have there. Same thing with this one, it would be x to the negative third. This is not a product, okay? This is a difference, they're being subtracted. This is a product, but again, we don't have a whole number exponent. The degree is the sum of the exponents of the variables. It's important that you understand that. The sum of the exponents of the variables, variables only. So, for example, it wants us to find the degree of each monomial, okay? So, I have a coefficient. How did I change the color all of a sudden? I have a coefficient, variable, variable, variable. Okay, exponent here, exponent here. I also have two exponents that I don't see, which is 1 and 1. A is to the first, B is to the first. Now, the degree we said is the sum of the exponents of the variables. That means that this one does not matter to us. We only want these. So I'm going to have 1 plus 1 plus 5. The degree of this monomial is 7. Okay? Down here, same situation. I don't care about the exponent of 7 because it's not a variable. So I have x, which is to the understood first, y to the third, z to the second. So I have 1 plus 3 plus 2. Okay? The sum of the exponents of the variables, and that's going to give us 6. So the degree of this monomial is 6. I want you to try and do C on your own paper. Please pause at this time. On C, we have the same sort of situation. We don't care about that coefficient exponent. Okay, so we're not even going to look at that. A is being raised to the understood first. B is to the third. C is to the first. So I have 1 plus 3 plus 1. So I have a degree of 5, okay? It's very important that you include the variables, even the ones, or not the variables, excuse me, the exponents, even the ones that you don't see, because they are still there. A polynomial is a monomial or sum or difference of monomials, okay? Monomial, we said earlier, means one term. Binomial, that bi, like your bicycle, has 2 wheels, so binomial has 2 terms. Trinomial, your tricycle, whenever you were little, had 3 wheels, and so a trinomial has 3 terms. Okay? The degree of a polynomial, because we're talking about multiple terms, is the highest degree of any of the individual terms. Okay? So you find the degree of each term in the polynomial, and the highest degree is the degree of the polynomial. The leading coefficient is the coefficient of the greatest degree term, okay? So that means that the term with the highest degree, the coefficient of that term is the leading coefficient. In standard form is when terms are ordered greatest to least, and that is by their degree. Greatest to least with degree. So, for example, it says to write each polynomial in standard form, which means I basically want to write them in descending exponential order, and then it wants me to find the leading coefficient. So, I'm going to start by writing the degree of each term above it. So, the degree of 8 would be 0 because there's no variable to have an exponent there, so it's 0. 5x squared, I just want that exponent to the variable, so it's going to be 2. X is being raised to the understood first, so that's 1, a degree of 1. And 7x to the third, this has a degree of 3. So I want to write this in standard form, which means I want my highest degree first. And I always want to take the sign that's out front, always. So I have, my first one is going to be 7x to the third because that's the highest degree. I'm done with that. It was a positive, I don't show a plus out in front, we know that. Then I have 2, which is going to be plus 5x squared. So I'm going to put plus 5x squared. Done with that one. Next is 1, which is the x, and it's a negative, so I'm going to put negative x. Done with that one. And finally I have 8. Doesn't have a sign in front, so I know it's an understood positive. 8. The leading coefficient is the coefficient that is in the lead. The coefficient, remember, is always going to be numerical, so it is going to be this 7 that is in the lead. That's my leading coefficient. I'm just going to put LC. I know what that means. Alright, on the next one. Same situation. I'm going to change colors here. Okay. 3a squared b. The degree of this term, I have a squared b to the first, so the degree of this term is going to be a 3, and I'll write it underneath here. 2b to the fourth, well, that's going to be the 4. Plus 5, it doesn't have a variable, so there's no exponent, so it's going to be 0 degree. And 6ab, a to the first, b to the first, so the sum of that is going to be 2. Now I need to write it in descending exponential order, or standard form. So the highest degree of these degrees that I have written down here is 4, which goes with this negative 2b to the fourth. So I'm going to write negative 2b to the fourth. Next, out of 3, 0, and 2 is 3, so I'm going to put plus 3a to the second b. Done with that. Then I have 2 minus 6ab. Done with that. And finally, plus 5. Okay, so I now have it in standard form. And this coefficient that's out in front, the lead, is going to be my leading coefficient. I would like for you to pause the video and try and do C on your own paper at this time. So, on C, we're going to start by writing what each degree is. So this one has a degree of x to the first, y to the first, which gives us a degree of 2. X to the second, y to the first, I add those together, I get a degree of 3. X to the third, y to the second, I add them together, I get a degree of 5. So the first term that I'm going to write is the one with the highest degree, which is 5. So I'm going to have negative 7 x to the third y squared, and that cancels out, I'm done with it. Then I have 3, which is going to be negative 2x squared y, and I'm done with that. And finally is my plus 3xy. And again, my leading coefficient is going to be that number that's out in front, so I have negative 7 as my leading coefficient. Now, if I didn't have a number out in front, say it was just x to the third y squared, there would be a coefficient. We just can't see it right now, right? If I had if this was my polynomial I was working with, my leading coefficient is still here, I just don't see it. It's an understood 1, so make sure that you are aware of that too. It says, add the polynomials, write the answer in standard form. These are some of my favorite problems because I think that they are so easy to do. All you're doing is you're adding this polynomial to this polynomial. And for us to add, we're just combining like terms. So I'm going to take what's in this polynomial and I'm going to just stack them under what it goes with. So I just have a squared, and since I'm adding, I can distribute the plus to all of those, but it's not going to change the signs. So I have plus a, whoops, I put that in the wrong place. See, okay, let's fix that. That's fine. Okay. Okay, so I have a squared, which I need to stack under its like term, which is going to be 3a squared. So I put plus a squared right under that. Then I have plus a, so I'm going to put that under the negative 6a, which is being added here, so I put plus a. Then finally I have negative 8, which is like terms with 5, which I just wrote a 5, so we'll make it an 8. And then I just underline it and I add or subtract whatever it says to do. So I have 5 minus 8 gives me a negative 3. Then I have negative 6a plus a gives me a negative 5a. 3a squared plus a squared gives me 4a squared. And then I have to bring down this last part, even though I didn't add anything to it, it's still part of my answer. And it wants me to write it in standard form. I have a degree of 4, 2, 1, 0. It's already from greatest to least, so I'm done. The same thing happens here. Okay, I'm adding each of these, so I'm going to take this positive and I'm going to just stack them under their like terms. So 7a is going to go under 3a, so I'm going to put plus 7a under here. Then this minus 3c has to go under 5c. Okay, and I'm going to go ahead and do that one first. So I have 5c minus 3c is going to be a positive 2c minus 2b. And then 3a plus 7a gives me 10a. And I still have to add that last polynomial, which is negative 2b plus 7c. So take that positive and take it to both. I have a negative 2b, which I'm going to stack under this negative 2b, and a positive 7c, which I will stack under this 2c. So 2c plus 7c is 9c, which is a positive. And negative 2b minus 2b is negative 4b, and my 10a comes straight down. Final answer. And it wants it in standard form, but because they all have the same, generally we will also write in alphabetical order, which they already are, and that's all I have. Now, this one is a little trickier because we're subtracting, and whenever you distribute a negative sign, it will change the sign of the number that you're talking about. So when I take this negative to each of these, because this was a positive, a negative and a positive gives me a negative now. This was a positive, that now gives me a negative. This was a positive, and it now gives me a negative. Okay, when I take the negative, it changes the sign. It's very important that you remember that. So I have negative 2z squared, which I'm going to stack under the 4z squared. So I'm done with that one. Negative 7z, I will put under negative 5z because they are like terms. Negative 3 is going to go under positive 3 because they are like terms. So I have positive 3 minus 3. Those just go to 0. I'm not going to show it in my answer. Negative 5z minus 7z gives me a negative 12z. And 4z squared minus 2z squared gives me 2z squared. Final answer, and it's already in standard form because this has a degree of 2, this has a degree of 1. I'm done. Same thing happens here, and I would like for you to try, whoops, too far. I would like for you to pause the video and try it on your own paper, please. So what we're going to start by doing is distributing that negative to every term inside the parentheses. Okay, so this is now a negative. This now gives me a negative. This is now a negative, and because this one was a negative, it's now a positive. Okay, so I have negative 10m to the third is like terms with negative 7m to the third, so I stack it under there. Negative m is going to go with negative m, like terms. Negative 2 is going to go with negative 3. And plus 2m squared is going to go with m squared. Underline all that. Pretend that that's a straight line. Negative 3 minus 2 gives me a negative 5. Negative m minus m gives me negative 2m. Negative 7m to the third minus 10m to the third gives me negative 17m to the third. And m squared plus m squared gives me 2m squared. So now on this one I have a degree of 2, of 3, of 1, and of 0. So I have to swap these two around to get it in standard form because I want that largest degree to be first. I have negative 17 m to the third plus 2m squared minus 2m minus 5. And that is my final answer. The perimeter of an isosceles triangle is 8m minus 11n. The length of each of the two congruent sides is 3m plus 8, or excuse me, minus 8n. Find a polynomial expression for the length of the other side of this triangle. Okay, so I know that an isosceles triangle has two congruent sides. That's not too bad for freehand. So I know that the length of the two congruent sides is this 3m, it's minus, I keep wanting to put plus, minus 8n. So this side is also 3m minus 8n. And I don't know this side right now, but I know that the perimeter is equal to that first number they gave me, which was 8m. I don't know how I keep changing the color randomly. And it just went back. How does that happen? Okay, minus 11n. So if you knew that this perimeter was 5 and that the two congruent sides were 6, you would take 6 plus 6 and you would subtract it from that 15. Okay? And in this case, we're going to do the exact same thing. We want to add the two sides we know and subtract it from the perimeter that we know to find this missing side. So, the two sides that I know are 3m minus 8n plus 3m minus 8n. And I'm going to take that positive to both. It doesn't change my sign. So 3m, I'm going to add 3m to 3m because they're like terms. Negative 8n, I will stack under its like term, which is negative 8n. And then I have negative 8n minus 8n is negative 16n. 3m plus 3m is 6m. So now that I know this, I'm going to subtract it from the perimeter that I know. So I have 8m minus 11n minus this one, which is going to be 6m minus 16n, which is the sum of the two sides that we knew. Now I'm going to take this negative and distribute it to everything inside, which is going to make this a negative and this a positive. So negative 6m goes with 8m, so I put negative 6m under here, plus 16n goes under negative 11n, and negative 11n plus 16n gives me 5n, which is positive. 8m minus 6m gives me 2m. This is my missing side length. That's all I have for you today. I hope that you've taken good notes and that you have a good night.